Imagine the world where the difference between success and failure depends on the reliable, millisecond or even nanosecond accurate and deterministic data delivery. This is common in critical systems such as automotive systems, industrial automation systems, or avionics, where the need for real-time communication is paramount. It requires advanced communication protocols and robust communication hardware to ensure that data arrives reliably, but also arrives exactly when it's needed. So let's take a look at two technologies that make this level of precision possible. In this video, we will take a look at time-sensitive networking and data distribution service extensions for TSN. TSN provides hardware framework for deterministic data delivery, while data distribution service extensions for TSN allows DDS to be integrated with TSN and achieve end-to-end determinism. Okay, let's take a look at the hardware part of the TSN system first. Time-sensitive networking is a set of IEEE standards that are designed to enhance capabilities of standard Ethernet. So it allows to send time-critical data with deterministic performance. But also it allows or provides the mechanisms that allows to send multiple types of traffic and share the same network. So the TSN provides time synchronization, low latencies, and reliable communication, which is necessary for application which needs real-time communication. Prior to these TSN standards, standard Ethernet didn't have any layer 2 deterministic capability. And as a TSN hardware, you can imagine switches and routers that provides TSN standards and supports these TSN standards. Okay, let's take a look at the software part of TSN network or system. DDS in a nutshell is a fully decentralized communication middleware for real-time communication between devices and applications with the ability to tune data sharing through QoS parameters. DDS was designed for real-time communication within the local area network and for critical systems that requires low latencies and or high throughput and brings the determinism to data sharing. This is very similar to TSN, but on the different levels of ISO reference network model. Because DDS is over the transport layer, which is level 4 in this reference model, but the TSN standards are within the layer 2, which is data link layer. So these are the differences. With the same goal in mind, there is no coincidence that new specification for DDS was created to be able to deploy DDS on TSN enabled network to take advantage of its capabilities. The DDS extensions for TSN specification describes how to design, how to configure, and how to deploy DDS applications to run over TSN. And since the TSN doesn't know anything about DDS, DDS has to provide a way how to configure the whole DDS and TSN system. So how to configure the whole system? These are the steps we need to take. First of all, you will design the DDS system as usual, with those participants, topics, readers and writers. Then you need to provide a deployment configuration, which states on which nodes the DD applications are running and what requirements have these DDS applications on the underlying TSN infrastructure in the terms of the resources needed. This is described in the TSN extension for DDS specification. After that, you will have all the information needed for the underlying TSN infrastructure, and you will have the configuration file in the form of a JSON or XML or YANG that can be used to configure the TSN infrastructure, which are routers and switches. From what you have heard, you can see that you need to know everything in advance to set it up properly. So you need to know devices and application, where they will run, on which nodes, and what routers and switches you will use. Getting it right, it's not an easy task, and you need a deep knowledge of DDS and TSN and networking as well. So the use cases will be very specific. For example, autonomous vehicles. It's a good example because you know everything what's in the car, so you can set it up properly. And I am sure that autonomous vehicles and avionics and military systems will be first adopters of these technologies. In conclusion, DDS and TSN are complementary technologies on different layers of reference network model, but integrating them will bring significant advancements for critical systems that need deterministic, reliable, and real-time communication. Bye.